Hi, good day everyone. I am Laura Imavilia and I will be your presenter for today. We will be discussing about the history of algebra. Mathematics as a subject can be broadly divided into three significant branches: arithmetic, algebra, and geometry. Algebra is considered to be one of the oldest components in the history of mathematics. It deals with the study of symbols, exponentials, known and unknown variables, and equations. So sit back, listen, and let's learn more about the history of algebra. So first, let me define to you what is algebra. The number theory, geometry, and their analysis put together to make an extensive part of mathematics which is known as algebra. In other words, algebra is a part of mathematics that deals with symbols and the rules to calculate those symbols. Now let's move to the important proponents of algebra. First, we have Muhammad ibn Musa al-Khwarizmi. He is the father of algebra. He was a Persian mathematician who wrote a book named Kitab al-Mutasar fi Hisab al-Gabar wa'i Mukabala in the Arabic language, which was translated into English as the compendious book on calculation by completion and balancing, from which the word algebra was derived. The book provides a systematic solution for linear and quadratic equations. According to Al-Khwarizmi, the word algebra is described as reduction and balancing of subtracted terms, that is, a transposition to other sides of the equation, or cancellation of like terms. His works have wide influence in mathematics, astronomy, and geography. Al-Khwarizmi gave a unifying theory that created a new revolution in mathematical history, where rational numbers, irrational numbers, geometrical magnitudes are treated as algebraic objects. The second important proponent in algebra is Amalie Emmy Noether. A German mathematician gave her contribution to abstract algebra. A famous theorem in mathematical physics has been titled in her name, known as Noether theorem. She developed the theories of rings, fields, and algebras. In physics, Noether theorem explains the connection between symmetry and conservation law. Emmy Noether was born in a Jewish family in Franconian for Max Noether, who was a mathematician. She studied mathematics at University of Erlangen. She worked at the Mathematical Institute of Erlangen in the supervision of Paul Gordon in 1907. In 1915, she got an invitation to join the University of Göttingen, a world-renowned center of mathematical research, from David Hilbert and Flex Glenn to join the mathematics department. She spent 4 years lecturing under David Hilbert's name. In 1919, she obtained rank of private docent after getting approval for her habilitation. Noether's mathematical work is divided into 3 epochs. First, contribution to theories of algebraic invariance and number fields. Second, Noether developed theory of ideals in commutative rings into a tool which had wide-ranging applications that was published in her paper Ideal Theory in Ringberichten. And third, she published papers on non-commutative algebras and hypercomplex numbers, and united the representation theory of groups with the theory of modules and ideals. Pavel Alexandros, Albert Einstein, Jean Diodan, Hermann Weyl, and Norbert Wiener described her as one of the most important women in the history of mathematics. Her contribution to abstract algebra earned her title the Mother of Algebra. For the developmental stages of algebra, the history of algebra started from Egyptian algebra to Babylonian algebra, Greek geometrical algebra, Diophantine algebra, Hindu algebra, Arabic algebra, to European algebra after 1500s, and finally to abstract algebra. There are 3 critical development stages in symbolic algebra, which is as follows: rhetorical algebra, syncopated algebra, and symbolic algebra. For rhetorical algebra, it was developed by ancient Babylonians where the equation was written in the form of words that remained up to the 16th century. Example, x plus 5 is equals to 8 is written as the thing plus 5 equal to 8. Syncopated algebra is an expression first appeared in Diophantus Arithmetica in 3rd century. Brahmagupta's Futa in 9th century, where few symbols were used and subtraction was used only once in the equation. For symbolic algebra, at this stage, all the symbols were used in algebra. Many Islamic mathematicians like Ibn al-Bana and al-Khalasadi wrote in their books about symbolic algebra. Francois Viet fully developed it in the 16th century. René Descartes introduced a modern notation that can solve geometrical problems in terms of algebra known as Cartesian geometry. In early algebra, quadratic equations played an important role, where it is said to belong one of the shown three equations. Greeks and Vedic Indian mathematicians developed two more stages of algebra, which lie between rhetorical and syncopated stages, known as geometric constructive stages. Now, let's talk about the contributions of different countries in algebra. For Babylon, ancient Babylonians developed a rhetorical stage of algebra where equations were written in the form of words. They used linear interpolation to approximate intermediate values as they were not interested more in exact solutions. Plimpton 322 tablet, one of the most famous tablets designed around 1900s to 1600s BC, gives the tables of Pythagorean triples. Following are the significant contributions. They developed flexible algebraic operations to eliminate fractions and factors by adding equals to equals and multiplying like quantities on both sides of the equation. They also knew simple forms of factoring, three-term quadratic equations with the positive term and cubic equations. For ancient Egypt, Ahmed, an Egyptian mathematician, wrote an Egyptian papyrus in 1650 BC known as the Rhind Papyrus, which is considered to be the most extensive ancient Egyptian mathematical document in history. They mainly used linear equations. The Rhind Papyrus contains problems of linear equation in the form of x plus xa equals b and x plus xa plus bx is equals to c, where a, b, and c are known terms and x is referred as aha or hip. The equations were solved by method of false position or regular falsi, in which a specific value is substituted to the left-hand side of the equation and obtained answer, after performing the required arithmetic operation, is compared to the right-hand side of the equation. For China, Zubi Suangjing is one of the oldest Chinese mathematical documents. The following are the 5 major books by Chinese mathematicians in algebra. First, we have 9 chapters on mathematical art. It is one of the most influential books that gives solutions for determining and indeterminate simultaneous linear equations using both positive and negative numbers. In one of the problems, it has a solution for 5 unknowns in 4 equations. See Mirror of the Circle Measurement. Li Zi wrote this book where he solved equations with the highest degree as 6 by using Horner's method, mathematical treatise in 9 sections. Qin Chu Shao, a wealthy governor and minister, invented the Chinese remainder theorem to solve simultaneous congruences. Magic Square. In this book, the author Yang Hui formed a magic square or matrix by placing coefficients and constants to solve simultaneous linear equations. He worked with column reduction methods to get the solution. Precious Mirror of the Four Elements. Chu Shi-che wrote his book in 1303 where unknown quantities in algebraic equations were represented as heaven, man, earth, and matter. Horner's method is used to solve the simultaneous equation with the highest degree of 14. Now for Greece. The Greek mathematician represented the sides of geometric objects, lines, and letters associated with them, which is called geometric algebra. They invented the application of areas to obtain the solutions for equations solved in geometric algebra. Following are a few Greek mathematicians whose contribution are the milestone in the history of algebra. First is Thymaeridus, created a famous rule called Bloom's of Thymaeridus, which states that if the sum of n quantities be given and also the sum of every pair containing a particular quantity, then this particular quantity is equals to 1 over n minus 2 of the difference between the sums of these pairs and the first given sum. Second is Euclid of Alexandria, called as Father of Geometry. He wrote a textbook named Elements, which provides the framework for generalizing formulae beyond the solution of particular problems into more general systems of stating and solving equations. In Euclid's time, line segments were considered magnitudes. They were solved using the theory of geometry, which in modern algebra is nothing but solving known and unknown magnitudes applying arithmetic operations. There are 14 propositions in Book 2 which are now known as geometric equivalents and trigonometry. Basic laws of addition and multiplication like distributive law, commutative law, and associative laws are geometrically proved in Book 5 and Book 7 of Elements. Proposition 5 proves the following equations geometrically. Proposition 6 and 11 gives the solution to quadratic equations geometrically. Data was another book written by Euclid for the School of Alexandria. It contains 15 definitions and 95 statements which serve as algebraic rules and formulas. The book has solution for dx squared plus b squared c minus adx is equals to 0. Diophantus, a Hellenistic mathematician who wrote Arithmetica, a treatise. 6 among 13 books have survived. He was the first to introduce symbols for unknown numbers, abbreviations for powers of numbers, relationships, and operations as used in syncopated algebra. The only difference between Diophantus' Arithmetica and modern algebra is special symbols for operations, exponentials, and relations. As for India, Indian mathematicians worked repeatedly on determinate and indeterminate linear quadratic equations, mensuration, and Pythagorean triplets. Here are some of their contributions. First, Aryabhata. He gave the following rules in his book Aryabhatiya. Brahmasphuta Siddhanta. Brahmagupta wrote Brahmasphuta Siddhanta, in which he gave solutions for general quadratic equations for both positive and negative roots. He gave Pythagorean triads M, like the equation shown in the screen, by using indeterminate analysis. He was the first to give a solution for the Diophantine linear equation ax plus by is equals to c, where a, b, and c are integers. Brahmagupta followed syncopated algebra, where addition, subtraction, and division are represented as given in the table. Abbreviations were used to denote multiplication, evolution, and unknown quantities. Bhaskara too. He is one of the leading Indian mathematicians of the 12th century. He wrote books titled Lilavati and Viha Ganita, where he gave solutions for determinate and indeterminate equations, linear and quadratic equations, and Pythagorean triples. He also gave a solution to Pell's equation. He denoted unknown variables as initial symbols of colors, and Bhaskara was best at giving solutions using indeterminate analysis. To sum it all up, the history of algebra almost started from the 9th century, and the contributions of mathematics of different countries are infinite. Modern algebra is the evolution of all their works, which has made it easy. The solution of quadratic equations with any number of exponentials can be obtained for both positive and negative integers by simple arithmetic analysis. Algebra can be viewed as a language of mathematics, playing a major role for students' opportunities to pursue many different types of education in a modern society. Thank you everyone for listening. I hope you have learned something. Bye!